early on Friday, yeah? Another reason why it'd be a bad idea tomorrow is I'm supposed to have devotions tomorrow, and I can't be in here waiting to give you your test if I'm in the teacher's meeting doing devotions. So, all right, here we go. Test on Friday. Let's go over integration. Hasn't that changed today? Brandon is gone. Jason is gone. Fred is gone. That's it. Okay. Number two. You guys have your colored pens, right? Okay. What do you have in your table? No. I just got it open. Oh. That was fun. Okay, give me a sec. We'll see until. But you still answer the question because I remember what was there. What's in the table? Acceleration. And what are they asking for? Velocity. How do I get velocity from acceleration? I have to integrate. But do I have a function or just a few values in a table? Oh, well, see, if I only have a few values in a table, then what am I supposed to do? Do they give me any other hints as to what to do? Aaron, is this productive talking? Just double checking. I can't hear it. So. Okay, so I see acceleration. Approximate velocity at 15 using a trapezoidal sum. What's going on? Using a trapezoidal sum, what's going on? Okay, I'm going to go ahead and insert a quick new page in my notes. Actually, we'll just go here because this is where it shows up in the packet. Because I can write a lot better on here than I can on that. For number 2, kiddos, tell me what you know about a trapezoidal sum. With trapezoids, yes, we're going to be using the area formula. 1/2 base times height 1 plus height 2. What are we using for bases? Almost always? Change in x's, right? What are we using for our heights? Almost always. Y values, right? Or f of x values. But hold on, what kind of y values do we have this time? We have a of t's. Those are our y's. If t's are our x's, then okay, so we need a of t values. So coming back. In this context, we have acceleration values for our y's, and we have t values, or delta t values, I should say, as our base. But what did trapezoids do? Why do we find area of trapezoids? Area with trapezoids approximates what? Better, but what does it approximate? The integral, the area under the curve. And the integral in this problem, we're going to use the area of trapezoids to integrate between 0 and, I think it's 15. Can you guys check the table? Yeah. You have to have a lower bound. You have to have an upper bound. And they say to use from 0 to 15. So, okay. And who are we integrating again? Okay. So let's go ahead and find the area of the trapezoids. We'll use it to approximate the integral, and then we'll try to answer whatever question they're asking. So, how many jumpity jump jumps do we have in our table? 1, 2, 3, 4, 5. So we're going to have 5 trapezoids. We're going to use the 1/2 base times height 1 plus height 2 formula. And what are the bases of each? What are the delta t's of each jumpity jump? Oh, so they're all 3? Well, that's going to simplify life a little bit. So when I start solving, I'm going to say, all right, I need A1, A2, A3, A4, A5 if you like setting it up like this. It's not bad. We can use the area formulas for all of them, which would be 1/2 base is 3. We'll get back to the heights in a second. Nice thing is, if you guys notice, since they're all 1/2 times 3, if we're plugging this in our calculator, what can we be doing? Yeah, we can just pull out the 3 and pull out the halves when we plug and chug it. Just because each of the jumpity jump jumps is the same. How are we going to find our heights? The y values. So for the first jumpity jump jump, what you guys get is your y1 plus y2, or height 1 plus height 2. Okay, finish it off for me because you guys should have it now. 4 plus 8, what was the next one? 8 plus 6, what was the next one? The next one. next one. So the cool thing is we could say, sweet, don't make any mental math errors. 12 plus 14 plus 15 plus 19 plus 20, right? When we plug and chug that, some of you guys have already gotten there. What do you get for your trapezoidal area?
Before the 3 halves or after?
After the 3 halves. 120? Which approximates the area. Now hold on, what are they actually asking for? Read the question again. What is, find the velocity at? Velocity at t equals 15. So is this an over or is this an at? Over a time interval or at 1? Ooh, if it's an at 1, the integration is net change. You guys had your forevers out a second ago. You were studying them. What is the formula for integration is net change? To find the final amount. Who am I trying to find the final amount or the amount of and at? Of velocity at t equals 15. Okay, so I would use the integration as net change, which says to find the final amount of f of b, but in this case, isn't it going to be v of b? I'm going to find v of b equals v of a plus the integral from a to b of, no, not v of t, v prime of t, which is a of t dt. Right? If you need to, go back to your integration as net change. To find the final amount of something, given the rates, we need to plug in. Same thing as v prime of t. So to find v of 15, what are we going to do? $15 is equal to v of who? Plus the integral from of a of t dt. What do we know from our problem that we can plug into this? Any clues? We know this integral is approximately 120. Right? They said use the trapezoidal to approximate the integral. That's cool and all. But what other clue do we have to pick out from the problem? This is the most common thing. If kiddos even know how to do trapezoidal sums, this is the most common thing to forget. Velocity started at 5 feet per second. So we have to say, okay, cool, the integral is the change in. That, it changes positive 120, but it starts from 5. So what would v of 15 be? 120%. And more specifically in context of the problem, if we had to stress about it, as you guys noticed, they're all feet per second, it would be feet per second. However, do you guys notice that they also have 120 as an answer? Wouldn't you feel good about that? Whew, I got the trapezoidal sum, that's awesome, I'm done. And then it's like, I didn't add 5. So the final answer should be D. Go back. Oh, to the work, yeah. The final answer should be D. So, integration is net change. How does it apply? We're finding the value of a quantity at when we're given clues about its derivative or its rate. Okay? That's an application of integration as net change. The integral tells us what changed, and we have to add that to the initial in order to be able to solve. Number 4, what changes? What do they give us now? Pollution in a lake. Ew, gross. Hey, at least we still have lakes. Go rain. Anyway, so we have a function. Did anybody figure out something very, very important that we have to read from this question or to get from this question? T is the number of years since 1995. Which means when I'm thinking about bounds, wait, why am I thinking about bounds? Oh, I'm going from tons per year to what? To tons. I gotta go back. Tons. Anyway, so I'm going from tons per year to tons. So I have to integrate. But when you integrate, you need to go ahead and make bounds. And what are my bounds? Someone already said it, Ryan. You said 1995 is what? 0, because we haven't gone away from 1995. So what would 2005 be if it's years since 1995? 10. And then all you gotta do is plug and chug that into your calculator, calculatrice. What's the integral from 0 to 10 of your function? What'd you guys get? 40. 40 even, eh? Sounds good. Does anybody have issues with their calculators? You guys working on it okay? 4 is supposed to be an easy one, but it's only easy if you know what to do, right? Gotta be able to interpret. All right, let's keep going. Number 9. Oh, I had this one in my notes. I don't have to be here. There we go. What was the very first thing you were supposed to be given in, or do in number 9, which is kind of lame. This is kind of a silly start to an FRQ. I haven't seen quite as silly of a start in the sense of giving away 3 points in a while. But what was it literally that you had to do in A? Draw it. How do you draw it? In your calculator. Why? Because it's a calculator problem. Oh. So, help me out real quick. I know that it goes down around 3-ish, and it goes up around 6.28-ish. More specifically 3.14, and more specifically 6.28. Sounds like pi a lot, and it is. But question, where does it start from? Oh, it starts from the origin?
Yeah.
How high does it go? About 6-ish? Okay. Where else does it hit? Yeah, what's that? Is it a big number? And then where does it go up again? So it hits at 9-ish, then it hits at 9-ish, then 12-ish, then where? 15-ish? Something like that? Okay. Question. All we have to do in A is graph, so what's going on in B? You guys should know from your forever cards. Forever cards. What does it take? What's going on when you're moving to the left? Someone tell me the clue. The velocity is negative. Who do I have in my graph? Velocity. How do I look in a graph for where the function is negative? It's when it is below. And I think actually I made it even more below than it's supposed to be. Wasn't it like barely below? Either way. Oh, that's about right? Maybe it should be a little lower. So when is the graph below? Well, did anybody find the intersections? What was going on at the first intersection? Wait a minute, didn't I say 3.14? How would you find them in your calculator? Find the 0. And he ends up being, if you would have looked at it, pi. Who's this guy end up being? Who's this guy end up being? Who's this guy end up being? Now, if you guys use decimals rounded to 3 places, that's totally cool. They would have taken that as well. Real quickly, check on people in your groups. Let's make sure that we're all awake and doing all right. Okay. So, what intervals? Wait, they say give a reason. Aw, stink. We have to put this in context. Okay, that's all right. We can use English, right? We can say that the particle is moving to the left for t within, all right, what intervals do you guys got? Pi to 2 pi. Pi to 4 pi. See if I can actually write the pi's down. And then where else? And 5 pi till, when are we supposed to stop? To 16. Technically, could I put a closed bracket at 16? Why? because the graph stops below. Does that make sense? So why didn't I do brackets anywhere here? They're not below, they're zeros, right? Okay, just making sure. But what would my reasoning be? Why am I going to put a comma, and why am I going to say since? They say explain. Yep, since v of t is less than 0 for those values. So look, guys, all we got to do is fill in the forever card and say, hey, we get it. Even if you had no clue how to answer, as far as with the numbers, couldn't you have said v of t is less than 0? Or a particle moves to the left when v of t is less than 0? You might have gotten a point without even writing any actual answers down. Go team. Go forever card. Yeah. Because if you look at your graph, I guess I went a little too far. If you look at your graph, it crosses at 15-ish and it ends negative. So at 16, the graph is below. Does that make sense? So at 16, on 16, the velocity is negative. Okay. Yeah. Sign chart is okay for you to think through it, but sadly, for giving a reason, you have to actually state that.
I did.
Oh, good. Never mind. You're good. Star was saying she uses a sign chart, and that's actually not a bad idea for maybe the rest of the problem, because couldn't you go ahead and plug in 0, plug in 16, plug in 1 pi, 2 pi, 3 pi, 4 pi? This could be your v of t, and this could be your behavior, and then you could say above, below, above, below, above. Hey, that might help too. Anyway, moving on. Total distance traveled, forever card. Come on, I told some of you guys, and some of you guys hopefully remembered it. What's the forever card? The integral of the absolute value of velocity, which they gave it to you as a function, right, cool kids? So, at this point, you shouldn't show me anything except for a number. What number did you get? Uh-oh, 13, I heard 9. Who's right? Uh-oh, I'm getting multiple 10 point. 542? You guys have to remember, when you solve math and 9, make sure number 1, you're using the right bounds. The problem says 0 to 16, like the big context, but this one says 0 to 4. How do I find absolute value in my calculator? Math over abs, right? We have to be very careful when we plug in our function that we are plugging it in correctly. Just a few of you might have made mistakes in plugging and chugging. Make sure, I'm in the wrong one. Make sure that you are in radians. Hopefully you're not in degrees. Calculus almost never, actually basically never, needs degrees. So we can use our, what happened? Did anybody borrow a calculator this morning from start? Does anybody see a calculator over to my right? Anyone?
Oh, sir. Yay.
Can you bring it on over to her, Ella?
Oh.
Okay. And then you need to put in the -1. So I'm pretty sure you guys are right. I just wanted to double check. There we go, -1.
I keep losing it.
It's easy to lose. Just don't lose it for the easy. DX and then done.
Oh.
Uh-oh. What happened, guys? V of t equals 2 sine of t minus 1, right? Absolute value, right? The bounds were, I'm in the wrong one yet again. Oh, I might be. Am I in pre-cal? 0 to 4. Okay, I'm in degrees, so that's obvious. That's wrong. Double check what you guys plugged in. We're going to get the final answer right now because I plugged it in correctly now. my goodness. Come on, calculator. The trauma is killing us.
What?
10.542. Double check. You gotta put abs. You gotta put big old parentheses. If you guys have the older calculator, you have to make sure you're in radians. Otherwise, you should be able to go. Question. Do we have any sort of units in this problem? Alright, so we're just gonna go ahead and box it and say you didn't tell us anything, so we're good. Shoop, shoop, shoop. But, real quick, you gotta put this and you gotta put that or else you're in trouble. Katrina. Pencil showing me that you tried. Letter D. Is there any time between 0 and 16 at which the particle returns to the origin? This is one of the trickiest, I think, that we've come across yet. Returns to the origin. Why are they talking about the origin? What did the original problem say about the motion going on in this problem? A particle moves along the x-axis. We've only learned how to do rectilinear motion. So it's a little like car sort of thing. A little car sort of thing. He's gonna move. And he's gonna move, and then 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 he's gonna move. Now, hold on. Some of you didn't catch that. He moves to the right. Wait, why am I moving to the right from the origin? Because number one, it says it starts at the origin, and number two, it's a positive velocity, so it's going to go to the right a lot and left a little. Wait, how did I do that? Why am I going right a lot and left a little? Look at all this area that shows positive displacement or displacement to the right, and then how much area shows to the left? Just a little bit. So when I'm up here, it's going to start at the origin, it's going to go right a lot, left a little, right a lot, left a little, right a lot, left a little. Question. Is it ever getting back to where it started if this is a periodic function doing the same thing over and over again? Nope. So how do we put that in math terms? I don't know. What did you guys come up with? Hold on. No, since the positive velocity is more than the negative velocity. That's not going to cut it. What else can we say? You have the right idea, but we have to say it succinctly and we have to say it exactly. Since the area of the top, the positive area is greater than the negative area. We can kind of say that. Here's a way of writing it with a little story without having to show tons of math. Did they ever name this function? Was it F? Was it Y? Was it V of T? Oh, that's right, velocity. Now, technically, we could use all these different numbers and talk about how this is a periodic function, which I tried to kind of put in with the periods and the continually moving. Since it's periodic, Long story short, and since the overall displacement for one of its periods is positive, it will only continue to move further away from the origin, more specifically further to the right of the origin. There are multiple ways of saying this, but you have to show your recognition of the fact that this area moving to the right will overcome or will be greater than moving to the left. So even though the function is, or the particle is moving to the right, then the left, then the right, then the left, the overall positive displacement will overcome or will be greater than the negative displacement, so it will only continue to keep moving further and further away. It can never return. They had many different ways of stating it that year in their answer key, many different student answers that they took. However, you have to be precise in your language and in your description, showing that you can tell what the math is doing. There is no possible way for it to return. Kiddos, we're not going to go over number 11 today just because, as you can tell, we're running short on time, and I want us to go look at those big idea problems. We'll probably cover 2 of them. I'm going to go ahead and cover, I think, the first one and the last one, just for your test review as you guys are working tonight. I think I'm going to cover the first one and the last one. Let's start with the last one, I think. So tomorrow we're going to go over number 11 really quickly. We're going to go over the other 2 big idea problems, and then we'll see if you guys have questions on your chapter review in your book. So if you have not done any attempt at number 11, you better have some pencil on there. Tomorrow I'm going to collect, not tomorrow, sorry, Friday I'm going to collect your notes. I'm going to collect your notes. I'm going to collect your homework files. And I'm going to collect this worksheet. I just need to see that you attempted 2 and 4 and 9 and 11, and you have 1 and 3 and 5 and 7 work as done in class. You are allowed to have red or colored pen marks, but it should not be the only markings for a problem. I should see some pencil attempt behind it. Does that make sense? Cool. All right. What do we do with this guy? Yeah, I was writing it in our notes. It's just like review big idea problems. You guys can label it number 4, because we're going to kind of work our way in a different order than I originally had planned because of time. We just have to integrate, conjugate, integral, right? Yeah.
So what do we do?
U-sub. Of course. The question, why am I going to first look at this guy? Some of you are like, arctan. Don't I have an X up top, guys? Because of some questions I was getting yesterday after school, I figured out that we need to review and say, hey, hold on. Original U sub would say take this entire guy, and if I have an X up top, that's a good sign, right? Okay, so let's see what happens. Let's choose U is equal to x squared plus 9. What would du be? 2x dx, which means dx is equal to du over 2x, right? So then when I go to plug in, I'm not scared of that 5x all over u plus 16 times du over 2x. I'm not scared of the 5x, but who should I be a little wary of? And here's the dilemma. With that plus 16, I am not allowed, it is illegal to do this step. That is horribly wrong. That is horribly wrong because this guy is tied and there is no x outside, which means I cannot cancel. Uh-oh. So I'm almost good. I like the 5x, but I don't like the 16. So what am I going to do? Now, hold on. Before I actually do that, I'm going to say, uh-oh, I should have done Hart method. I should have done Hart method. And then I would be plugging into 5x over x squared plus 9. I can use this u sub for the part with the x, but I can't use that u sub for the part with the 16, and we'll talk about why in a second. But if you get to a point like that where you're like, I'm not scared of the x term, I need him for my du, but I'm scared of that extra number, that's an indicator we should have done Hart method at the beginning. So if you see an x up above and you see an x squared down below, or like an x squared up above and an x cubed down below, that's fine for u sub. Try it out, but if you have someone extra, maybe you should have done the heart method. Now let's go ahead and use that u sub that we've done over here on the right, and let's say, okay, we got this. Plugging in, we end up with, we can pull the 5 out, right? X over u times du over 2x. We're golden for this guy. If you want to, since you're working on this side already, you can go ahead and keep working, pull out the 1/2, so 5/2. Integral of 1 over u du. And how do we solve that guy, guys? Yeah, ln. Of who? Of his u. And who is his u? X squared plus 9, right? Now some of you put a plus c, but remember, aren't we solving a bigger problem? So let's put the plus c out here and say, oh, that's right, we still have a whole other guy to go. So let's go ahead and take the other guy and say, all right, how should we solve u? Figure out the 16, that's a good idea. Why am I going to start talking about a's? Yeah, arctan. So I have all this, I'm like, wait a minute, he's good to go. I have u squared plus a squared. Dx is just du. So can't I go ahead and just make this plus 16, wait a minute, times 1 over a, right? Arctan or tangent inverse of u over a, which would be x over 3. There's our plus c. The only thing I would point out to you guys before boxing it and being done is right here with the absolute value. Kiddos, do we need absolute value with x squared plus 9? Nope, that's always positive. X squared is always positive. Adding 9 will always just make it more positive. I did not need the absolute values after all. So what made heart method good for this problem? I had my x, which was good for my du when I chose it for the entire denominator. But 16 needed to be its own guy over here for arctan. Does that make sense? Okay. You guys, some of you might have gotten stuck in one of those types of problems in the 4-7 homework, and you might see it again in the chapter review. We're not going to be able to finish the other big problem I wanted to look at, but first we're going to peek at him really fast. Why is this guy not a pretty just simple, well, wait a minute, why don't I just choose this as my u? Oh, if I chose that as my u, wouldn't my du be 2 minus 2x? Do I have anybody to help me out with that? No. Okay, so we know it can't be normal u sub, which means I should be thinking of an arc trig, but which arc trig is this closest to? Why is it arc sine? A, do you see the negative? And B, do you see there's nobody outside for arc secant? So how do I go about solving this? I need to make him match, so I say, all right. The 8, I'm not scared of. I need the minus, so I'm going to pull a minus from the x squared terms. But I need to do what to get this to be a u squared? I need to complete the square, right? To complete the square, I take the middle term, I take -2, I divide by 2, and I square him. I'm adding 1. Why am I also adding 1 on the outside? Doesn't make sense. Hold on, wait. Balance it. There's a minus, right? So that's a -1, that's a +1. Then hopefully you guys get to a place where it's a lot easier to do. All right, cool kids. I'm just rewriting him. You guys can go ahead and go work on your test review in your book tonight, okay? Come with questions tomorrow.
Violet.
Yeah. You can see it because you have me right there. He doesn't. At least I have to go do something. What am I
They're bright. See
I know you're joking. You're doing that on purpose. You're so dumb. Yeah. Do you not speak English?
English? Oh,